It's important for us to talk about 4.2e, and I'm going to explain why replication, control, and random assignment are important for an experimental design. When you control an experiment, you're actually controlling for the lurking variables that actually might affect your response. To do this, you actually want to use a comparative design and ensure that the only systematic difference between the two groups is the treatments that are being administered. So really, this is how you set up your design in terms of controlling for the variables. Step 2 is your random assignment. Here we're just going to use impersonal chance to assign experimental units to the treatments. This in itself helps to create roughly equivalent groups of experimental units by balancing the effects of the lurking variables that aren't controlled on the treatment groups. So the treatments themselves are set up here under the control, but the random assignment will help control for things that aren't covered within the treatment aspect. Now, the replication, for this one, we use replication. Doesn't mean to repeat itself. It means to actually use enough experimental units in each group so that any differences in the effects of the treatment can be distinguished from chance differences between groups. What this means on replication is use a large enough sample size. So don't have too small of a sample size in this case. And then the last thing that is important that we have not talked about yet, but we will, is blocking and blinding on an experiment if we need to. If we look back at the caffeine example where we had our 30 volunteers, 15 had a caffeinated cola, 15 had a decaf cola, we want to explain how to use the principles of element design in the caffeine experiment. So how do you actually control within that one? The best way to say that the control for here is this. There should be a control group that receives non-caffeinated cola. Subjects in each group should receive exactly the same amount of cola served at the same temperature. Each of the colas should look and taste exactly the same and have the same amount of sugar. So in this case, either choose to do diet or regular soda. Subjects should drink cola at the same rate and wait until the same amount of time before measuring their pulse rates. If all the lurking variables are controlled, they will not be confounded with the caffeine or be an additional source of variability in the pulse rate. So what you see here is the control is how did you set up this experiment? Did you control for everything? We want to be very specific in telling you how fast to drink the cola, making sure that everyone has the same amount of sugar. If you give someone a non-caffeine sugar cola and a caffeine diet cola, that's not comparable. So it's just set up and design the experiment with as much detail as possible. Now the randomness. For random assignment, we would say subjects should be randomly assigned to one of the two treatments. This should be roughly balance out the effects of the lurking variables that we cannot control. We can't control body size or caffeine tolerance or the amount of food that someone recently ate, especially body size for this. When you do random assignment, it's going to account for these other things that we couldn't establish under the actual experiment itself. Again, such as the body size. We can't control for that, but random assignment can. Then the last piece here is how do you talk about the replication? Remember, replication just means a large enough sample size. So we want to use as many subjects as possible to make the treatment groups as equivalent as possible. This will give us better chance to see the effects of caffeine, if there are any, on our subjects.